Good morning, dear ladies and gentlemen. Welcome to our webinar. Today we would like to talk again about hybrid cloud technologies. It's really a very important and burning topic in current condition with the global chip crisis and different logistics issues in the world. And today we would like to talk especially about data analytics and data management. My name is Oleg Arsenyev and I'm responsible for business development in ITGLOBAL.com. As well, I would like to introduce our experts for today from NetApp, our reliable partner, Mathieu van Schaik and Pascal de Wild, senior solutions engineers from NetApp. Hi, Mathieu. Hi, Pascal.
Hi, Oleg. Good morning.
Hey, good morning.
Morning. And the plan for today is the following. So I will start with a small introduction and a quick description of our company, and then Mathieu will go into the details of data management, data analytics in hybrid cloud. So you may ask questions in the Q&A interface, and we will have the Q&A session at the end of the webinar where we will try to answer all your questions. Okay, let's start. As I already mentioned, I represent ITGLOBAL.com. For those who are first time on our webinar, ITGLOBAL is an international group of companies. We provide different IT services, product solutions, IT integration. Since 2008, we work with virtualization, IS, cloud services. We were among first VMware partners at the time, so we already have more than 14 years of successful experience on this field. We designed and deployed our own cloud infrastructure in reliable data centers in different countries like Netherlands, like United States, Canada. And we provide their public cloud solutions, private cloud, managed IT services, and so on. We already serve for more than 1,000 customers worldwide, have many partners in different regions, and we try to cover all IT needs of our customers just to help them to focus on their core business. So let's go to the next slide. And here I would like to share some observations based on our experience regarding modern IT tendencies and hybrid cloud. I think it's good to start with a definition. In general words, hybrid cloud is understood as a mixed computing, storage, and service environments composed of an on-premises infrastructure, private cloud, public cloud, maybe hyperscalers like Amazon or Web Services or Azure, with orchestration between these platforms. And I would like to mention here that the future of IT infrastructure in our understanding is hybrid. So nowadays we see that already more than 90% of our enterprise customers use hybrid approach, either with different cloud providers or with physically distributed infrastructure. It's quite typical strategy almost for all of the companies. The big companies who has their own huge infrastructure, they usually are looking for cost efficiency, scalability, disaster recovery, etc. And then they go to some cloud solutions like private, then with public. The small companies, they usually start with a kind of economic approach in a public cloud with hyperscalers, but with the growth, they're looking for guaranteed performance, for information security, etc., and they go to a private cloud environment, partially to on-premises solution, and the results in both cases are the same. So it's kind of hybrid IT infrastructure. So let's go to the next slide and see what challenges the company may face with hybrid cloud. Today, we would like to focus on data-related challenges. You know, in our information age, with the development of big data technologies, Internet of Things, social media, etc., working with data is one of the key tasks for modern companies. You may have data arrays from different sources, structured, not structured, and based on the efficiency, quality, and speed of your work with the data, your company may win or lose. And recently even appeared the special knowledge section like data science and data scientists like professionals. And hybrid cloud approach actually is one of the powerful technological solutions that may help you to improve your work with the data. And the main challenges here are the following. So first is design of this data, storage data environment. So where it should be placed, what types of cloud, what kind of providers, how security should be organized, how the scalability can be managed, not scalability in terms of storage, also in terms of computing power, different access rules, recovery procedures, how to make the processing quickly, how to speed up all these data analytic procedures, and also integrate new tools when they appear. Another challenge is the distributed teams, because many scientists may work from different locations, different places, but they need to work in one environment, but usually with their personal workspaces. And hybrid cloud is actually the tool that can help you to do this work efficient. And NetApp has specific tools to guarantee you these things. Also, another thing is the management of this data environment of storage. In general, data scientists, they are not like IT administrators. That is why it's very important to make these management tools simple and efficient. And this is like requirement from the industry at the moment. That is why we ask NetApp experts to share their knowledge and technologies that helps to data analysts to explain how it can be organized, how it can work. And another challenge that is also always very important, it's new technologies, new tools, because the data science is in rapid development phase at the moment. So that's why it's very important to be up to date, to understand what new software solutions, hardware innovations, new algorithms appear. And we recommend to be always on top, up to date with all these things. That is why we make these kind of webinars to help our customers to be aware of best achievements of the most reliable, the most efficient industry leaders, and get benefits from these solutions. And now I would like to pass the word to Mathieu, Senior Solutions Engineers of NetApp, who will tell us and show probably those highly efficient tools for data analytics that may help your companies and your business.
Okay, thank you, Oleg. This is a perfect slide. It more or less already summarizes what I will show you the next, say, 40 minutes. Well, let's start. We are talking about the data analytics in a hybrid cloud environment. I'm Mathieu, or Mathieu if it's pronounced in the Netherlands, Mathieu van Schaik. I'm a Senior Solution Engineer of NetApp. And I'm joined with Pascal de Wild, who also a Senior Solution Engineer and a direct colleague of mine, who did the previous two webinars the last 2 weeks. This webinar differs a bit from the last two in a way that I'll focus now on one of the fields where lots of data is used, this data analytics. So it's the first part of this webinar will be seen more from an application point of view, and the second part will be more on a product kind of view. Well, data analytics, you use lots of data, and we make it easier for you to use it. So as I said, it will be divided in two parts. NetApp for the data scientists, and that's the tool which Oleg also talked already about, how to make the work for data scientists easier, how to speed up your work, and well, also reduce costs. And the second part sorry, will be about what do we have as NetApp for tools and products for data analytics as a whole. The data management tools, cloud services, which we can use in the data analytics field. First part, the NetApp for the data scientists. So let's focus on the people who are doing data analytics and how to make it easier for those people to do their job and to get to the data and to speed up their work. Why? First of all, because data scientists normally are not IT people. They come from lots of different educations, but not necessarily be schooled in IT work. So there are no computer scientists. But because of data analytics, they need to work with lots and lots of data, but then from an application point of view. So they need to access data. Typical things of data scientists is feature extraction, data cleaning, and all that kind of things. Modeling, machine learning, or deep learning modeling, using toolkits like the Schaik learning toolkits. So more the application point of view of the data. So they do need the data, they do need versioning, they do need saving results and that kind of things. And they do need cooperation with other scientists. So it's so they do need a lot of work with data, but they are not the IT admins. They do not want to rely on IT admins for copying data or for supplying data. They want to do that themselves, and we have developed a toolkit for them to make it more easier. And we call that the Data Operations Toolkit. So, in short, what if data scientists could copy, share, and move data within seconds and focus on experimenting on data? So their task is working with data, experimenting on data, and not the IT-related tasks to get to the data. For that, we developed the Data Operations Toolkit, meant for the data scientists to accelerate their common storage tasks. And that instead of being dependent on the storage administrator, I need a new volume. Please get me a new volume. Okay, just shoot in a help desk task and we'll do it for you when we have time. No, they want to do it immediately. And we have the toolkit to integrate in their daily work so that they do not need to know all the specific storage details, but they can just launch commands just from their, say, Jupyter workspaces. So what is our NetApp Data Ops Toolkit? In a sense, it's a NetApp Python library. Yeah. And when you're coding in Python or you're working from Jupyter workspaces, you can add in that library next to your libraries for pandas, Seaborn, Scikit, Learn, and that kind of libraries, and just apply our library into your workspaces. The slide says use NetApp solutions without storage knowledge. Okay, I would not say that in these words, but it's more like integrating your storage related tasks into your workspace. So if you do need to create a new volume, you don't need to go to ONTAP System Manager, or you don't need to go to a CLI and do a create volume, but you can implement it within your own environment. I'll show you in a minute. We do have two versions. one for the traditional environments and one for Kubernetes environments. So if you're working with cloud-aware in cloud-aware environments with Kubernetes and containers, we can also apply this toolkit as well. This is more or less a schematic what it looks like. We do have on the bottom, we do have our NetApp storage or ONTAP related storage, either on premise or in the cloud, or our specific NetApp AI solutions, which we have together with NVIDIA. And a strange sign here, the BGFS is a parallel file system, and we also have integrated our DataOps toolkit with the BGFS parallel file system with NetApp E-series storage underneath it. We can use or apply the toolkit within our Jupyter notebooks. Of course, we can also use it from the normal IDE environments, so more CLI-like and terminal-like, and we can integrate it in an automatic data pipeline, a data pipeline, if we use tools like Kubeflow. Main goal for this toolkit is to the second line here, to provide access to advanced features that would normally require help from storage admin. So it's more a toolkit where admin of IT admin, storage admin tasks are delegated to the data scientist itself. So they can speed up their work and are not dependent from the IT department. This is how it looks like, more or less. We have our application compute environment here, and the DataOps toolkit is more is an interface between the application compute side and the storage side here. And the storage can be on-premise, it can be in cloud. Later on, I'll show you a lot of things, and it can be in object storage environments. How does it look like? And what does it do especially? Well, the DataOps toolkit allows you to clone volumes, data volumes. And cloning in NetApp terms means thin cloning. And what means, well, okay, we clone a snapshot, and we make that snapshot available to you as a read-writable clone. So we don't copy the data, but we make it available for you only. So it won't copy your original volume, but it makes available the pointers to the data to you. Well, we can clone volumes, we can create and we can delete volumes, we can create snapshots to get moments in time backups, and we can move data from and to object storage. S3 object storage, for example, our NetApp storage suite. How to integrate that into your Jupyter Workspace environment? Here you see, for example, the command create snapshots, and then, of course, a bunch of parameters, clone a volume, and I'll show you that in a moment in a demo. So there's some basic storage-related tasks, creating snapshots, working with volumes, and transferring data from one point to another point, like pulling and pushing to object store. Why does this benefit you and your organization? It's because with cloning, we have one data source, and with thin clones which do not occupy additional space unless you change your data. Then the changes will be stored, but otherwise it just uses through the clone the data stored in the cold source in this example. So instead, and that's written down here, say I do need 5 clones, then instead of 5 times 100 gig, yeah, I just clone the cold source without occupying additional space, and it remains more or less 100 gig with some overhead. Yeah, a clone is a very fast operation. It's done in seconds or minutes, a couple of minutes. And if you have to copy that amount of data, it might take you, lots of minutes or hours. And if you also would be dependent from storage admin, and it can take you much more time before you can access your data space. Sorry. So it can save you a lot of time. It can save the organization costs because of not requiring to duplicate all the data. So it's a very nice tool to use. I told there is a traditional environment and there is a Kubernetes environment. And here it is, this slide shows the functions available within the Kubernetes environment if you're working with containers managed by Kubernetes. There's a small distinction. All those functions here, creating workspaces, creating, deleting volumes, cloning, snapshotting, and that kind of activities can be done in an ONTAP environment. All can be done in an ONTAP environment. Then we use the container storage interface provided by Trident. If we work in a BGFF parallel file system environment, that's not with underlying ONTAP operating system, and this environment does not have access to the ONTAP snapshotting and flex cloning mechanisms. So these type of activities, cloning from volumes and working with snapshots, are not possible in the BGFS environment, but it is possible in ONTAP environment using Trident. Well, what then, to summarize the Data Ops Toolkit, what are the advantages? Well, the first one, the increase of speed. Again, the cloning of data, of volumes, and access the data clones and the data volumes without needing any help of admins. Makes it work faster for you, more efficient. We can integrate it into an artificial intelligence control plane, so an automated data pipeline. The access to data means we're working with persistent data on backend storage. You can mount to that storage and you can work with that storage, so you have easy access to that storage. The traceability of experiments is also a repetition of cloning. You can clone your data, so each and every data scientist can have his or her own workspace based on a persistent volume of a persistent data set. And if they are done with their experiments, they can either throw away the data they tested on or save the results, whatever they want to do. If an experiment fails, you can throw away your working copy, clone again from the main data source, and start all over again within minutes. again an example of increase of speed and also of the traceability. Traceability also means the user snapshots to save tested models, save the data sets together with the models where you tested on, so you can repeat it in whenever needed. So there are some of the advantages of the data toolkit. Now I'll let you show you in short how this works. I'll stop this slideshow and hopefully I'll see my demo environment. Yes. And now you see a Jupyter workspace. And I'll just run through this workbook and let you show how it does work. Execute a few of the commands. Importing of libraries. It's just all based on Python and Python libraries. So we do have the pandas, the matplotlib, the numpys. This example also the datetime library. And here we have the data ops traditional toolkit. And from that library, for this demo, there will be imported things to do with volumes, clone, create, delete, list, mount. These are some of the functions which can be integrated into my workflows. I can work with snapshots, create, delete, list, restore from. I can work with Cloud Sync, which is a tool I will mention later on to copy and replicate data. Same with SnapMirror. Our SnapMirror is our replication engine from ONTAP. And I can work with S3 object storage to push and pull, push and pull, push, push, pull, pull. So this kind of functions are now available to include in my workspace. Today imported. Now volumes. Here the list volumes command. Which volumes are now available? Which are mounted? Well, there's a volume name called taxi data. It's an ONTAP flex group. It's mounted from this system at this directory. Now, it's not a clone, well, and some other information. Well, you can see what's in that volume. There is a file called live demo CSV. I want to preserve this information, so I do make a clone. Create of I do want to make a clone. Before making a clone, I have to create a snapshot because clones are created from snapshots. So I create a snapshot first using this volume taxi data, give it a name, and print and list the snapshots. Yeah. Here the snapshot name is the time point data. It's created today, 5th of April. Well, here it is 9:30, so it's created at 9:30. Well, we can see the snapshot that has been created. We clone it. We clone. We name the clone taxi data instant copy. We clone it from the volume name taxi data and especially from the snapshots within that volume, the time point data. Yeah, volume clone created, mounted, created, mounting and mounted successfully. We list again the volumes, should be another one now. And look into the data, and here we see again the live demo CSV.gz. Just within my normal Jupyter environment, I issued a few storage commands, which otherwise I would have used for system admin or system manager or the CLI to do it. Now, reading data. Where am I here? Well, it does all kinds of things with the data, but it's a panda function reading that file from this volume. Yeah. So, and then it do some things to make it more visible. It's say 3 million entries. Some of the entries are 0 because there's not everywhere the same number of fields. It looks like the top and bottom of the file looks like this. It has lots of fields. And if we do visualize the data, it's a taxi data set showing the number of rides per day for one specific cab driver. It should be here now. Yeah. Looks rather funny, but that's normally the case with data scientists. This data scientist works. You have to clean up the data. You have to do something about the missing data, that kind of things. Now, this one, for the sake of time, I skipped this one. Well, main task of data science is cleaning up data and that kind of things. So we make an in-memory copy. We do some cleaning. Especially we're interested in data from 2017, 18, and 19. So everything before and after that will be removed. We will remove fair amounts being 0. And we will remove passenger counts being 0. So the cab driver should have passengers. Okay, we've done that. And then we see all columns are now completely the same. Althans, they all have values now. So we've skipped all odd data. Now, let's show the same graph as before. Now, this looks better. Now, then you can, if you do, then you could do all kinds of other things, data scientists and modeling things, whatever you want to do. Let's skip that. So now we've done what we should have done, and I want to save the data in a new volume. So I create a new volume. List it. There is the volume, data cleaned. This was the original. This is the newly created. This is the snapshot. It's the snapshot I previously created. I write the data to a CSV file to that new data cleaned volume. Take some time. It are 3 million lines which have to be written to the storage. I don't know what systems are behind this this environment, so it takes some time. You can see that with this asterisk here, then it's work in progress. In the data clean, new data clean volume, we have now new clean data CSV file. We'll delete, we'll do some cleanup. Delete the clone volume, the text data instant copy. And we delete the snapshot. So now it's only the original volume and the new volume. we delete the snapshot. And the snapshot has been deleted successfully. Well, that's in a very short an example of how to include storage-related commands into your workspace. Storage-related commands, getting data from NetApp environments, storing data in NetApp environments, making working copies by snapshotting and cloning data, and that kind of things. Let's continue with the presentation. Normally I should get me back here. Yes. Well, that was the first part. Second part. Let's see. Yep. Second part is okay. What do we have as infrastructure and services from NetApp, which data analytic environments can profit from? There'll be a bird's eye view, just an overview of what we have, and partly it will overlap with the previous two webinars given by Pascal the last 2 weeks. Well, in general, in this kind of data analytics environments, AI environments, machine learning, deep learning environments, we have the data at different locations. Sorry, it's not uncommon if data somewhere enters in an edge environment, if you have data, if you have sensors in the field, your IoT and that kind of thing, it's somewhere data is generated, has to be ingested, there has to be done some pre-preparation work on the ingested side, then it has to be transferred normally to a core environment where data is prepared, cleaned, and whatever more or less things I showed you in the demo just a minute ago. And then train the data, seeing which machine learning, deep learning model best fit the data for what you want to do with your data, and then deploy it when you have your correct model. And it's not only the core, but more and more cloud environments are also involved, because the cloud environments from Google, from Amazon, from Microsoft Azure, there are so many tools already available for analyzing your data, to do everything with your data you want. So it's already there. You do not have to buy it for your on-prem environment. You do not have to develop it for your environment. You can just apply it when you are capable to put your data in the cloud and apply it to the applications already there. So this the data should be at more places during the complete process. And we do have tools and infrastructure, to store the data and to transfer the data and do other things as well. And here's a very short overview, concise overview of what products and services we do have, and I want to run to a few of those. I see I have, say, 10 minutes left, so it will be very fast now. Just to give you a few examples. NetApp at the edge. This is an example. Okay, we do have our sensors, we do have cameras, and we store that on a very small NetApp all-flash system, and then from there we can we can move it to the core if we want to. On-tap can be physical hardware, like the system shown in the example, but it can also be a software-defined on-tap, so we can run ONTAP on commodity service. We can run ONTAP in the cloud on cloud instances. So we ingest the data and then we have to move it normally to a core environment where it can be further processed and cleaned and whatever. We do have some tools for that. If, like the previous example, data is ingested in on an ONTAP environment, we have our SnapMirror ONTAP to ONTAP replication, synchronization, backup tool for moving the data storage-based from one side to the other side. Storage-based means a very efficient transfer of data. And if we also use SnapMirror for the synchronizing data, then it will only synchronize the differences from the source and the target. If it's not on ONTAP, or we have different protocols from the edge, on the edge, and what we use at the core, then we have a SaaS tool called Cloud Sync. I'll let you show that in the next slide. Or we can use our NetApp XCP data migration and replication tool as well. And we can also share data, so not copy data, but share data or caching data. So we have one data source again, and which can be used at multiple sites. The Cloud Sync, we can use that if we have to do a protocol transfer. Say we do have an NFS, like we ingest data as NFS, and it has to be used in an application which uses object storage. Then we can use Cloud Sync to convert NFS protocol data to object stored data. We can move or transfer data from an on-prem environment to a cloud environment and back. We can use this tool to move or transfer or replicate data from Azure to, say, AWS or to Google Cloud. So it's a transparent data migration, copying, synchronization tool between different platforms and different protocols. It's a completely managed, NetApp managed SaaS service, so it's very easy to use. And it uses a lot of parallelization to speed up the data migration tasks and speed up the process. It can use, say, all of the bandwidth available between source and target by spinning up more parallel processes. Now, XCP is more or less the same, but it's a command line tool for on-premise work normally. Just an example on the right side, an existing example. If we do have a BGFS environment, parallel file system environment for HPC kind of works, and we have well, the persistent data center storage somewhere in the data center in an NFS3 environment, and BGFS uses NFS4. We have to convert from NFS3 to NFS4, and we can use the Cloud Sync or XCP to copy the data into the BGFS environment and together, and as well as convert the data from NFS3 to data NFS4. That kind of things. Well, we use this kind of transferring and replication tools as well in our own environment. If you're a NetApp customer, you have a problem, you have to upload some log files. Say you are in Australia, you can upload it to an object storage environment. Amazon will replicate it to another region. There we pick up the data with Cloud Sync, just mentioned, to storage grid environments, and there we can use in our support centers. We can do things with the logs, what we ever have to do with the logs, for example. apart from copying or migrating or replicating data, we can also share data. We have two facilities to share data, and that is both based on caching. The one is NetApp Flex Cache. We have a main data source here, and we can make this data source as available as a cache in an ONTAP environment, for example, in the cloud, within Amazon, within Azure, and also only copy the data which is required at that moment in time. So we do not need to copy the complete data volume, but only the active data at that time, and that is being used. Two advantages: we do not need to have as much data of capacity as the complete data source. We can do with say 10-20% of the capacity, and for the people working in this environment can access the data here instead of all the added latency back to the data center. It can be vice versa as well. And the same with managed cloud, managed SaaS service called Global File Cache, but that's for a Windows environment. We can have one data source and make it available at the edge, and only those parts which are actively used at the edge. So the same profits, do not need to have all capacity here, only the capacity which is needed, and low latency compared to situations without the cache, where you have to latency from here to there instead of from here to here. Yeah. Well, NetApp is known. NetApp at the core. We've already done the data toolkit. NetApp is known for the performance and scalability. This is a slide from Pascal from last week or the week before that. We can scale out, we can scale up, and we can make it an unlimited growth environment. Same for the PGFS environment, where we use building blocks, and we can add building blocks, add to building blocks, and get to several petabytes of storage as a large HPC cluster. We do have good cooperation with NVIDIA. We do have specific artificial intelligence infrastructures. Let's show you that in the next slide. At the core and also in the cloud, we do have some cost reduction facilities. Cloud tiering I'll let you show in a slide in a couple of minutes. But here also, because of the high availability of our systems, both the ONTAP and the E-series environments, are known for the 5 to 6 nines of availability. So they're very solid environments, and we can say that can save lots of money when you compare it to solutions where you have lots of servers with their own storage, with the DAS storage. There you quite often have to do multiple copies of the data just in case one of the servers fails. And with centralized storage with E-series and ONTAP, you don't need to have several copies, and the rate, the DDP, and erasure coding redundancy together with the high available hardware saves you a lot of capacity and that kind of thing. So also this kind of environments are more economical than if you are working with server-based solutions. As I told, we're working closely together with NVIDIA for AI infrastructure solutions. We have solutions with the NVIDIA GGX 800 modules for ONTAP, for where we do indeed have the GGX modules. We can have a FlexPod environment. We have a FlexPod AI, where the NVIDIA cards are implemented in Cisco UCS compute nodes. And also we have the NVIDIA modules in the BGFS NetApp environment. Those are validated reference architecture, which means they have already been proven. We do have deployment guides how to install and deploy those solutions. Well, it's proven solution, so you can't go wrong. Just read that yesterday. We again received an Artificial Intelligence Excellence Award for our solutions in the field of natural language processing. So our solutions are recognized in this typical industry. It's net a bit of core. Let's finish this in a while. I also said, well, we do facilitate cost savings, and especially we support things like automatic cloud tiering. Normally in data analytics field, you do need very fast storage. Fast storage, normally expensive storage. If you've done your primary experiments and you go over you go on to the next experiment, yeah, the data still on that expensive storage, taking space, taking up capacity, making the solution more expensive. With cloud tiering, we can offload or tier out data which has not been used for a specific amount of time, say a month or 2 weeks, to less expensive object storage, either in the cloud or with our own object storage solution, Storage Grid. So instead of expanding your expensive clouds or flash storage or NVMe storage, we can move the cold or inactive storage data to a less expensive tier. And the cost for this storage on object storage is less or much less than if you would have kept it on your expensive NVMe storage systems. So it's transparent for you as a user. All data is accessed through the high performance storage environment. If data is requested, which has already been tiered out to the object storage, it will be transparently loaded back to the high performance environment. It's a way to reduce your total infrastructure costs. It's very, yeah, it's one of our standard facilities now in our all-flash environment, all-flash environment. We also use this in our own environment. Yeah, NetApp customers know we do have active IQ, so we receive from all systems data, and that will be lots of 7 billion data points daily, apparently. We do something with it on our high-speed production environment. If we are done doing what we have to do, we tier it out to a data lake. Then we call it warm data, and even all the data we tier down again to even less expensive storage. We save a lot of money by doing this kind of tiering mechanisms compared to keeping all data on this high expensive environment. Now, NetApp in the cloud, Pascal already has done that last couple of weeks. We can have ONTAP in the cloud. ONTAP in the cloud, we call it Cloud Forms ONTAP. If you're already an on-prem or ITGLOBAL customer using ONTAP, then it's the same ONTAP. You can do the same things. You can easily migrate data from on-premise to the cloud. It's just the same way of working as usual. And we have what we have called things like Azure NetApp files or AWS FSx for ONTAP, or Cloud Volume Services for GCP. Then there are first-party services from those cloud providers, NetApp technology, which can be made available to the applications you run in the cloud environments. It's just another type of cloud storage, but not just. It is characterized, for example, for its performance. It's the cloud volume services, the Azure NetApp files can reach up to enormous performance, up to 128 MIPS per terabyte, or 32,000 IOPS per terabyte. So if you really do need very fast cloud storage, we do provide it for you. Just to give you an example, the Azure version of it, the Azure NetApp files, is certified by SAP HANA as cloud storage for their application environments. Now, Spot by NetApp already told last week, just to reduce the cost of your cloud compute environments by controlling, monitoring your reserved instances, on-demand instances, and Spot instances, just to optimize the whole thing. And well, the last one actually already told a few times. No, not told. Just if you have your container Kubernetes environment, you do need some persistent storage. We do have our container storage products like Trident to couple your container volumes with persistent storage, which we store on NetApp. In this case, the Azure NetApp files in the cloud, and in this example, on the BGFS file system. So that's a way that we can help you with your container storage environments. Well, that's what I wanted to tell. We do have our Data Science Toolkit and integrated in an AI control plane. I've let you shown this. We have a data fabric for solutions in the edge, from the edge, in the core, in the cloud, and how to transfer data from and to it. We do have AI solutions together with NVIDIA. Well, data pipeline is the same as the core to edge, edge to core to cloud. And very important, we do have very high performance and high available solutions for you to store your data and guard your data. This one I skip. A few resources. The Data Toolkit, DataOps Toolkit. Here some links to modern data analytics on netapp.com. We have a very extensive blog site with lots of blogs also on AI, on NetApp, and also on the PEP. And well, if you like the things which I showed you with the Jupyter workbook, then here's a nice course to get acquainted to this kind of things. So that's what I wanted to tell. As NetApp, we are the experts of data management. So we can do that for you, and let your data scientists focus on the data science, and we will handle the rest. That's my part. Back to Oleg.
Thank you, Mathieu. For me, it was really very interesting presentation, and I think it's very useful for data scientists and experts. There are a lot of very powerful tools, I think, and actually NetApp, I think it's the best company that makes data management and data systems, data solutions now. To the all attendees who were able to watch until this moment, so we have a promo code. So this is ITGLOBAL 1 hybrid. So you can use this promo code when you actually want to have service with us. You can get 1 month of free public or private cloud. So please use it to get services. And also, if you are interested in data management solutions, also we provide the help. We provide part of the portfolio that was shown by Mathieu and Pascal, and of course we can develop specific solutions according to your needs. I think now it's a time for questions and answers. So do we have any questions? Mathieu, I think we can go to the next slide to share the contact information. If you have some questions, you can ask by email, so to get in contact with our team and with the team of NetApp. There were some questions. Are any data scientists in the call interested in this? So please, data scientists, share your information about you in the chat, just to understand if you're here. Then we have a question, on what principle business user cases do companies decide how much computing power they need to budget? Or is that based on the type of business applications? Well, I think it's more question to me. So yes, it is based on the requirements. So part of the work of IT department is to design the infrastructure. So it's how much storage, how much computing power, memory do you need, how you design your infrastructure. So actually, if you have these kind of questions, you can contact us after the webinar. So we will be more than happy to help you with all your questions, concerns, and other things. Mm-hmm. Any more questions? What are the guarantees for privacy and security of data?
Mm-hmm. I can take that one. The guarantees for privacy and security of data, yeah, when it's stored on our NetApp systems, say our ONTAP systems are built with trust from the ground up. So it's a very secure environment. You can, well, we can protect the data any way you want. We can encrypt the data. We can shield the data, we can back up the data. So yeah, it's dependent on the platform where you store the data. And if that's a very reliable platform, and it is, then we can, yeah, then it is guaranteed. That is, actually, I refer to the NetApp ONTAP platform for this. Yeah.
Yes, I would like to add that actually the security and privacy, it's like usually you should use like multi-level approach, because like on the different level of your infrastructure, you have some instruments for security. So you can put the security on the data center level or on the cloud environment level, also on the database level. Also, you have based on NetApp services, NetApp his own tools of the security. Also, you need to maintain the security in your internal business processes. Your business process in the company should be organized in a way to guarantee that the information is properly kept. And it is also part of the design of IT infrastructure. And we as ITGLOBAL, we help also to do this kind of design to maximize the security and protection of your data. And of course, NetApp in its tools has the maximum level of privacy security that can be guaranteed if you do the correct configuration and proper design of the solution. Another question, importing of libraries with Jupyter. What if the codes are written in Java? Does it work with other languages besides Python?
That's specifically a Python library. So sorry for that, but Python only.
Jupyter is a Python library, so
because Python
no way.
Currently one of the very popular to use in this kind of environment. So that's the reason why we've developed it for Python.
Thank you. So any more questions? I do not see any more questions, and I think we are a little bit out of our why do you transfer data first from hot to warm and not directly to cold?
Oh, this was just a specific example how our own IT department implemented our Active IQ. In this case, I guess from hot to warm to cold, because warm is the data lake and expect that they do need some access to it as well, but not for high-speed analyzing tools. For a normal cloud tiering or data fabric pool, we do from hot to cold immediately. That's not a process. That's the on-tap process we normally use to reduce costs and and to save expensive high-speed storage. So from hot to cold is our normal on-tap behavior, but it was a specific example which is used in our IT department. So there are more ways to do to achieve cost savings, and it's the application which directs what best can be done.
Thank you. So it's a question of design. So actually, different options are possible.
Yeah, sure. Thanks for the question.
Thank you. Thanks for the questions. I think I don't see any more questions at the moment. So if you will have any more questions later on, so please don't hesitate to share them with us, contacting by email or by phone, or using our channel on YouTube, where all this video will be located later on. So thank you, Mathieu. Thank you, Pascal.
You're welcome.
Thank you, all the participants.
Yes, thanks all.
Have a good day.